This is for general math specialists. It's integration by linear substitution. So if I got the integral of x times the square root of x plus 1 dx, I have no methods available to take that integral. If I consider my square root, the derivative of the square root is 1, so I've got this x sitting around here, and I don't have a product rule. You might ask, well, why don't I put the x back inside the square root and get something like the square root of x cubed plus x squared? But I can't anti-differentiate that because I need its derivative, which would be 3x squared plus 2x, and I don't have it. That's not a method to follow. What I'm going to do is the bit that is underneath the square root, I'm going to make that equal to u. So u equals x plus 1. Which means du dx equals 1, therefore du equals dx. So I can replace the dx with du because they are equal. U equals x plus 1, so therefore I can rearrange that for x equals u minus 1 by moving the 1 from the right hand side to the left hand side. So now I'm ready for my substitutions. I'm going to substitute everything. I'm going to substitute x with u minus 1. I'm going to substitute x plus 1 with u. And I'm going to replace dx with du. They're my three substitutions. So this is going to look like the indefinite integral of x, which is u minus 1, times the square root of x plus 1, which is the square root of u, dx, which is du. I can now multiply this out, and it's going to give me u to the 3 on 2 minus u to the 1/2 du. And now I can integrate that. It's going to equal u to the 5 on 2 divided by 5 on 2 minus u to the 3 on 2 divided by 3 on 2 plus some constant c. Another example. I can't anti-differentiate this because 3x includes an x. 2x plus 1 to the power of 4, I need its derivative. So I'm going to make this bit equal to u. So u equals 2x plus 1. Therefore, du dx equals 2. Therefore, du equals 2 dx. And if u equals 2x plus 1, therefore x equals u minus 1 all over 2. Okay, so now I'm ready. I don't have a 2, so I need a 2 there. So I'm going to put out a half out the front to counterbalance that. So 3x is going to equal 3u minus 3 all over 2. So looking at all of my substitutions, my 3x equals that, and that will replace 3x. 2x plus 1 equals u, so 2x plus 1 will be replaced with u. And 2 dx equals du, so I'm going to replace 2 dx with du. So it's going to equal a half integral of 3u minus 3 times u to the power of 4 du. Now I've got a half there, but I'm going to bring that out the front and make out the front 1/4. So I've replaced 3x with 3u minus 3 over 2. I've replaced 2x plus 1 with u, and I've replaced 2 dx with du. So now I have 1/4 integral of 3u to the 5 minus 3u to the 4 du. which will equal 1/4 times 3u to the 6 on 6 minus 3u to the 5 on 5 plus some constant c. 3 goes into 6 twice, therefore I've got u to the 6 on 8 minus 3u to the 5 on 20 plus some constant c is my answer.